let's look at 11 first. If you look at number 11, this is the picture. So what kind of an angle do we have here? What kind of angle is, I'm going to go ahead and mark it, 6x minus 7. What is that angle called? Well, we hope it's obtuse. It looks obtuse, so let's be more specific. What did we learn last class? Exterior, right? So exterior angle, and then these two are called the, what? So we put an R. We're going to control the TV. A remote interior angle. We know that the formula, I guess, the theorem that we did with the exterior angle theorem says that the exterior angle is equal to the remote interior angles added together. The sum of the two remotes. So yes, since you asked me for this, I would hope you would write this down. Right? I know Josh is beautiful. Okay. So let's go ahead and solve this. I have an algebra. Did everybody get the K that was supposed to? I think so. Right? Did you all get it? Okay. So let's look here. Let me. All right. So let's look at this equation. How do I solve it? What's the first step? Add like terms, and which I have here is x and 2x, negative x and 2x. So I have 103 plus x. I have x's on both sides of the equation. So what do I do? So subtract x, maybe. If I subtract x, I'm going to have 5x minus 7 is equal to 103. Now what? Add 7. So I have 5x is equal to 110. Divide by 5. X is 110, not 100. I said it right. 22. This is the exterior angle here. Straightforward. You'll have something like this on your quiz next class as well. Okay? So that's why I gave these back to you. It's a good study guide kind of for you. Especially, and then the definitions in your full book too. All right, the other one you guys asked for was 14, right? Okay. So let's look at 14 as well. 14 was a little harder if I remember. This is one where you had several triangles together. Not exactly drawn like that, but you get the idea. It's not drawn to scale. 80, I believe. Okay. So what you need to do in this case is you need to treat the triangles separately. So I'm going to start by looking at this triangle here. Okay, just this triangle. And this triangle here, I have 2 of the 3 angles. So I'm actually going to find this angle right here, because it's the other angle in the triangle. So if I add 62 and 50, I get 112. And subtract that from 180, what do I have left? Okay, so I know that that angle right there is 68 degrees. I'm going to do the same thing, but this time I'm going to look at this triangle. Okay, and I have this triangle, I have 53 and 80. When I add those together and subtract from 180, what's left? What do you get? 47? 47 looks right. So I have 47. Now I'm going to look at just the triangle on the inside. So I'm just going to look at this guy right here. I'm going to draw it a little bigger so we can see it. Okay? I have a triangle with 47 degrees, a triangle with 68 degrees, and I just need to find this one. 65 degrees is what's left. So this guy here is 65 degrees. What's x? Y. Because they're vertical. But so x is 65. Doing okay? Feel a little better? You can figure out your mistakes you made maybe? With the ones that you guys got wrong? Only a handful of us got them all right. So I want to make sure if you have questions, let me know. Okay then. If you would, check your answers to your homework. Are there any questions from the homework then? You go ahead and put that worksheet right in your triangle properties section of your binder. Okay? You should have a divider for triangle properties now. What homework questions do you guys have? Any? Nothing? Can I show so impressed with Reese because I told you to put holes across the top like this. Reese put them here. Anybody else do that? You're a genius. You know why he did that? Because then otherwise it would hang out of your notebook. So he put it in this way. You're so smart. Right? Anyway, you did a good job. Mine, I know. I had to do this is what mine looks like. The folded top, right? Does yours look like that too? Exactly. I mean, I wasn't thinking. Where were you when I was putting holes in mine? Anyway, okay. Any questions on homework at all? Emma, do you see where you made your mistake? On 30? What's your 30? Is your angle A, I believe. Right? Want to go over any of them? No, I see them all. All right, then. We went ahead during when I'm checking homework, and we did this little activity where we kind of made a decision about what's true about what kind of sides can make a triangle. Okay? So, we're going to summarize this, okay, with the relationship in one sentence. How can we summarize what we did with the sticks, the different colors of the sticks here? We said that the two smaller sides have to be what? Bigger than the third side. So in order to make a triangle, we should probably say this somewhere. I think we'll probably do it in our foldable, so you can get that foldable out from us. But in order to create a triangle, I'll show you where to write it in just a minute. The sum of the two smaller sides has to be bigger than the third. I'm going to show you in a minute. Two smaller ones cannot be smaller. They can't equal. It has to be absolutely bigger than the third side. Okay. So in your foldable, I want you to copy this into the top part of the next page. So we should be on right after the exterior angle theorem, I think. Does that sound right? So we should be folding on the next page here, and I want you to write it up here. Copy this whole page. What side lengths can make a triangle? And I want you to put that right on top. Okay? Right up here. Everything you see there, except for the blue, goes in there. So let's look at what side lengths can make a triangle. And I've just given us 3 examples here, really for us to kind of decide, yes or no, they will make a triangle or they won't. So that a little exploragon activity that we did at the beginning of class is going to really help us decide this. Let's look at the first one, 3, 4, and 8. Would they, yes or no, make a triangle, and why?
No.
Ooh, I hear no and I hear yes. So who says no? Why do you say no? Josh, you said it pretty loud. Why do you say no? Because 3 and 4 added together is not bigger than 8. It has to be bigger, right? So this would be a no. No triangle. Okay? Let's look at the second set. 3, 4, and 7. Yes or no? Do they make a triangle?
No.
They're the ones that actually equal. So when you try to make a triangle, what kind of happened with the two smaller? Kind of just made it a flat line, didn't it? It didn't actually pop up and make a triangle. So this is also no. Because 3 plus 4 equals 7. Can't equal, has to be bigger. So this would be no triangle also. What about 3, 4, and 6? Yeah, because the two smaller ones, 3 and 4, add to be a number that's larger than a third side. So yes, finally, this one will make a triangle. Okay? Now, we're going to learn eventually what kind of triangle, because I can tell you it'll either be an obtuse triangle, a right triangle, or an acute triangle. And we'll learn exactly how to figure that out in a little while, not today. But they do make a triangle. Good. Okay, so that should all be in your foldable, right? Good. So, let's look at these examples here. I want you to decide yes or no. You don't have to write them down unless you have room, you can. Is it possible to draw a triangle with side lengths of 40 millimeters, 18 millimeters, and 23? Yes or no?
Yes.
See some nodding. Why yes?
We are getting my phone.
Okay, so we're not always adding the What do they add up to be?
41.
41, which is bigger than 40, right? So it's going to be barely a triangle, but it'll be a triangle nonetheless. So yes. Can you kind of imagine what kind of a triangle it would be? Would it be acute, obtuse, right? It'd be very obtuse because it barely makes that triangle, right? 41 is barely bigger than 40. Good. All right, how about over here? Side lengths of 9, 8, and 2. Do they make a triangle? Yeah, because the two smallest ones do add up to be bigger than a third. Good. Pretty easy stuff, right? Can it be yes or no is really the question. A little bit harder when I ask you this question. What are the possible side measures for the missing side? So I want you to really think about this because there's definitely more than one answer. I'm going to pause the recording and I want you to talk about people. I'm going to talk to the people at your table. Talk to your partner. And I want you to think about, come up with at least one answer. Okay? If you can come up with all of the answers, I'll give you candy. Okay? So talk to your people at your table. Let's decide what all of the answers are if you can. All right, so we do have a winner. How do we get it?
So because it's all like impossible answers, so we need to say kind of like put a limit, like one is complete and one is stop.
Okay.
So we need to make kind of like a set of numbers.
We're going to do an inequality. So you need to write this down if you're done. Okay? So we're going to do an inequality. We have a top range and we have a bottom range. Now, most everybody got the bottom range. You all knew that it had to be bigger than 1, right? I had 1.01, 1.00001. But it can be any number bigger than 1. I agree with that. Almost everybody got that far. It's the top range that people messed up with. A lot of people were saying less than 6 or less than 5. How'd you get that number? You could have 6. Let's try 6. Does 6 work? If I had 5, 6, and 6, wouldn't the two smallest add up to be bigger than the third side? So 6 works. Does 7 work? Does 8 work? Where does it stop? 11. Because if you get 5, 6, and 11, now they don't add up. Right? So how did we get 1 and 11? Well, you take the two numbers that were given to us, and you add them together. That gives you the top range. And then how would you get the bottom range? You subtract them. Okay? Well, I don't think that's simple. I'll be honest with you. I think that would be pretty, I mean, it's simple how to get it now, but I mean, like, I think it's hard to get there. I think it's pretty, it's pretty good that you guys got that. The bottom number is 1, because you subtracted them. You subtract them, you get the bottom number, and you add them to the top number. Any number in between 1 and 11 can't equal 1, can't equal 11. Any number in between those would work, would create a triangle. Okay? We good so far? You will see this again. Promise. All right. So, let's see if we can come up with an inequality here. You don't have to write this one down because you already have an example, but let's try it. What are the possible measures for the third side here? Because it's a range of values, when it says all possible, that should be our clue that we're going to write an inequality. Okay? The third side has to be between what and what? 1 and 5. And I actually, this is going to be something that I'm going to be a little particular about. Oh, really? We know it's between 1 and 5. I agree. Here's something. I just automatically made it an X. Well, it's really a question mark. But what variable could I use? You actually have to use Z. So let me show you why. Because angle Z, this is called side Z. The angle that's across from the side, or the side that's across from the angle, has the same letter. Angles have capital letters, sides have lowercase. So 2 would be lowercase y. 3 would be lowercase x. Okay? So across from the angle, we really should put a Z. Does that make sense? I didn't put letters, that's why I put an X there.
Kind of like the opposite of the angle, like
Yep, the side opposite of the angle. And we're going to look at that a little bit more because we're going to be looking at something called the triangle inequality, which we're going to be ordering sides and ordering things as well. But let's look at one more. Find all possible measures for x, y, or yx. What would you get? And again, what letter should we use here? Side z, right? So side z is in between what and what? 2 and 18. Like, I mean, it's real basic. Once you figure out the strategy, it's easy. What did you say? Once you get it. All right. So this is the last thing we're going to put in our triangle foldable today. Go on the bottom half, and then we'll actually put something on the back at the after the quiz next time. Let's copy this one in. The largest side of a triangle is across from the largest angle. It's called on the bottom. It's called the triangle inequality. Okay? The largest side is across from the largest angle. We're actually going to be ordering sides. So don't make this fill up the whole thing. Put this example a little off to the side. We can put another example with it also. Okay? But for now, let's put this, and this goes on the bottom. Again, put it like on half of the bottom. If you want the other half for some things as well. I think we're missing an angle here. Can we find it? Sure. Of course we can. What does angle C measure? 110. Because you know the triangle sum theorem, you know that all the angles of the triangle add up to 180. So we can find that easy. So you can kind of think about it. If I had a real big obtuse angle like angle C here, it's going to open up to the largest side. So the side that's across from it will in fact be the largest side, or the longest side. We can label that in two ways. We can label that side AB as a segment like we normally do, or we can just call it side lowercase c. Would you agree? Either one is okay and acceptable to me. Because remember, if you're naming sides, you need to use lowercase letters, or you can label it as a segment like that. Okay? Which side would be the shortest? The shortest one would be across from the shortest or the smallest angle. So in this case, it would be this one. So it would be side AC. Because 30 is the smallest side, right? Or 30 is the smallest angle. Oftentimes on the SOL, they ask you to order the sides. Okay? Put them in order. And I've seen them go from smallest to largest. I've seen them go from largest to smallest. They just want you to order them. So let's order the sides, or we could even order the angles if we're getting the side right. And let's order the sides from smallest to largest. So what would be the smallest side? You already have it. AC. We'll use the two letters. Okay? What's the next smallest side? CD, BC, either way, it doesn't matter how you write it. And then the largest side would be AB. So I've seen them where you have to order them like that. No big deal. Can you imagine on an SOL dragging, like if they gave you these three sides in different orders, having to drag them into the correct order on a box? You can see that too. Like on an SOL, there's a drag and drop question or something like that, or drag into the right place. I've seen that before. All right, so each of you and your partner has a little Ziploc bag. I want someone to decide if they're going to be the person that does the examples or if the person's going to do the you try. There are 8 total questions in here, 4 examples, example 1, 2, 3, 4, and then 4 you tries, I believe. 1, 2, 3, 4. So decide who's going to do the examples and who's going to do the you try. The one that came up that somebody was asking about was this one. I'm not sure if it was a you try or a example 4. Okay. Can we all look at this one? Example 3. Okay. I'm not sure which one it was, but this one was a little harder. I know for sure what the largest angle is. I know for sure. Which angle is the largest? One angle. Oh, you can leave it with 3 letters. That's fine. I can say angles. ACB is the same. Because it's across from the largest side, I know that angle C, as Marvin said, angle ACB is fine. Okay? Largest angle. My question is, which one is the smallest? they are the same. Because this is an isosceles triangle, the two sides are congruent. They are across from this side, this angle 3 is across, this side 3 is across from angle B. These two angles are congruent as well. The base angles of an isosceles triangle are congruent. They are the same. So they are both the smallest angles. Okay, so that's, you would have to say angle A and angle B are both the smallest. Were there any others that you came across that you weren't sure about? Okay, let's look at this one. You tried number 4. We have 12, K, L, 26, 16, and M. I want to find the smallest angle. Actually, why don't we just order the angles? Can we do that? Let's order the angles. Let's go from largest to smallest this time. What's the largest angle? L. Because it's across from the 26, right? So angle L is the largest. What's the next largest angle? Damn it, I heard K. Actually K, because the next largest side is 16. And that would leave the smallest angle to be M. Okay? Good. All right, if you would please put the little piece of paper back in the little Ziploc bag for me. And then I have one problem I want you to write this example in the other side of that foldable. So right down here at the bottom, I told you to leave some space. I'm going to turn down the light so you can see it a little bit better, but I want you to copy this example into here. Why is this one so much more difficult than the ones that we did with the little you tries on your paper? What's different about this problem? It's two triangles we have to deal with. Right. So we kind of have to look at them individually and then make a decision from there. Okay? When they share a side, the side that they share will be the smallest side in one of the triangles, and it will be the largest side in the other. Which means that the length BC is really going to be in the middle because it's the shared side. Okay? So your shared side goes in the middle. Okay? And again, I'm going to say it one more time. It is the largest side in one of the triangles, and it's the smallest side in the other. So let's kind of make a decision here. Which side is it the largest? ACD. Good. This triangle here that I'm getting ready to highlight, side BC, the shared side, is the largest side of that triangle. It's the hypotenuse. It's across from a 90. Maybe we should fill in some of the missing angles too. Does that help a little bit? So let's do that all as well. So let's fill in. So this angle here has got to be what? 60. Put that in. How can I find some others? You have to have those parallel lines. You see it? So angle CBD. So angle CBD, this angle here, is what degrees? It is 60. Okay, you can do it that way, or these two angles are alternate interiors, either one. As long as the lines are parallel, alternate interior angles are congruent. That'll work too. Or you can do it your way. Knowing that 60, what's the measure of angle BCD? Look at the other triangle. Let's find its measure. 70. Good. Because 60, 50 is 110, and 70 would be 180. So now we have, yes.
So since the angle ABD, we don't know which part of the angle.
You know it's a right angle. Because ABD and angle A are the parallel lines, right? Yes, you have to have parallel angles. All right, so let's go back to looking at the other triangle. Let's just look at one at a time. You already told me that we know the shared side is the largest one here. So let's look at only triangle ABC. triangle ABC. Let's just see what that would be. What's the shortest side in only triangle ABC? I heard AB, I heard AC, I heard... What's the shortest side? AC, from the across from 30. AC. What's the next shortest side? AB, across from the 60. So double check. Is that the correct order from shortest to longest for just the highlighted triangle? You agree? Okay. Now I want to look at the unhighlighted triangle, and it's going to be triangle BCD. Okay? Now, if you look at that one, isn't 50 the smallest angle? So doesn't it make sense that the shared side, side BC, is the smallest side? Because it's across from the 50, right? So what's the next smallest side? Well, the next smallest angle is 60, so across from it would be CD. And then the largest is going to be across from the 70, which would be BD. Okay? How do you feel? I have one more. You don't have to put it in your foldable, but you should put it on the paper that you did with the U-tries and the little, the little piece of paper that you did. I have one more example. I want you to try these on your own, okay? So I want you to try this one. Draw this picture on your paper into your notes. You should label these notes, by the way, to triangle inequality. So you have for your notebook. Today's date is, gosh, 13th, right? No, 12th. It was the Veterans Day. So triangle inequality. And then today's date is 12th. So go ahead and put this one into your notes and let's see if we can't order these. But again, from shortest to longest. Right. We know the shared side is LN, so the length of LN should go in the center of our inequality. It's the smallest in one triangle and the largest in another. Which one is it in the largest? Which triangle is the largest of? LKM. So this side here is going to be triangle LKM. That just helps me kind of organize my thoughts a little bit. So I'm only going to be looking at LKM. What's the missing angle? What do you get? 55? 45? 45 looks better, not yet. 45. It's 45, 35, and 100 add up to 180. Oh, brilliant. So which is the smallest side in that triangle? KM. Very good. And then the next smallest? KL. Good. Now we're going to look at the other triangle. And it's going to be triangle LNM. What's the missing angle there? That one's the, there's different answers. It's 55. Because 55, 30, and 95 add up to 180. So we know that LM is the smallest because 30 is the smallest angle. What's the next size? LN. Good. And then the largest in the whole figure would be MN. And it looks that way too, doesn't it? It looks like it's the largest. Okay, so what I have given you, when you came in, you guys had triangles, triangles, and more triangles, a little packet there on your desk. So go ahead and open it up for me. We're going to skip around a little bit in the packet, okay? The first couple of pages are more of a review for yourself, because you can do this review. If you open it up, the exterior angle theorem, there's about 8 problems there. Kind of a practice if you wanted to practice and study for your quiz, because remember you have a quiz next class, right? Triangle inequality notes, again, you can go ahead and summarize that as a review if you want. But your actual homework begins when it says triangle inequality practice homework. So find that sheet here, the triangle inequality practice. I believe there are 18 problems there. And so you have 18 problems. I'm still not done. Okay? And then if you turn to the next page, you have several multiple choice questions. I believe the bottom says 2 and 3. But it's like, I think there are 9 multiple choice questions on the front and back of the next page. Do you see that? So I want you to do the 9 multiple choice questions on the next page. Okay? Are we okay? Both pages are due. Front and back, this one. Remember, this one is a front and back. It's your next class. You also have a quiz. Okay? So I will say you also have a quiz to study. The quiz is not on what we did today. So what is the quiz on? So classifying triangles, both by angles and sides. Can you tell me it's obtuse, acute, right? Scalene, equiangular, equilateral, isosceles. And then you're going to do the exterior angle and interior